energy advisor to, I forgot and I lost count on how many presidents in the US. This is the day after the 4th of July, and this is the day before we start meeting all those energy efficiency targets. We're going to focus, Amory, on efficiency within the transport sector, because that's the main aim of the 2030 arena, and that's the toughest climate target that Sweden has. I'm going to leave the floor to you to guide us through a better, sustainable, more efficient future. And we're with us also Tomas Kåberger. Presentation not necessary, so I'll skip that just so that we can give the floor directly to you. Amory, the floor is yours. A warm welcome.
Thank you. I think we are all aware now that if we design a building as a whole system, it can work better and cost less than if we just optimize the parts of it in isolation. So, for example, Judy and I grow bananas in our passive solar house near Aspen, Colorado, with temperatures to minus 44 in the old days, before global weirding. And we don't have a heating system, and it's cheaper to build without one because the house is so well insulated, it doesn't need one, and we save more construction costs leaving out the heating system than we pay extra for the things that got rid of the heating system. A lot of people don't realize you can apply exactly the same logic to designing factories, processes, equipment, and vehicles. So, for example, I drive a German car made of carbon fiber, the BMW i3, which has been on the market now for 9 years. And at the time, carbon fiber was thought to be an absurdly expensive, ultralight, strong material to make cars out of. You could only afford this for handmade race cars. But Uli Krantz's team realized that if they optimized the whole car as a system and around cost per car, not cost per kilogram, they could actually produce a very competitive car, and they did. It was the most popular electric vehicle in Europe in 2018. They sold 250,000 of them already. It's out for another year if you still want one. And they made money on every one of them. How did they afford this costly material? Well, by, first of all, needing a lot fewer batteries to move less weight. The car's hundreds of kilos lighter. Batteries are the most expensive part of an electric car. And then making the car turned out to be much cheaper because the manufacturing required only a third the normal investment in water and half the normal energy, space, and time. So altogether, the re-optimized ultralight car, or at least lightweight car, didn't cost more than a regular version made of metal. And the conditions were also much better for the workers, and the quadrupled efficiency on the German test, 1.4 liters per 100 kilometers, came without compromise and with many driver advantages, of which my favorite is that the turn radius is half normal, so it's very agile in the city. But technology moves on. I advise a couple of companies aiming to market this year cars that are 2 or 3 times more efficient than even a Tesla. One of them is a rather odd-looking, extremely streamlined car. In fact, it has less air drag than just the side mirrors of the most popular American pickup truck. You can look it up at Aptera, aptera.us, and it gets better than 0.7 liters equivalent per 100 kilometers. In fact, it's so efficient that the 3 square meters of solar cells on top can drive it 40 to 60 kilometers a day. In other words, it will handle standard commuting requirements without ever plugging in, although if you do want a very long road trip, you can get it with batteries that can be recharged quickly from normal household current for ranges up to 1,600 kilometers. Then there is an ordinary-looking and quite beautiful 5-seat car. The Aptera is only 2 seats, And it's made by Lightyear, a Dutch firm from the team that 6 times in a row won the solar race car competition, so they know a lot about cars. And they're going into production in Finland in September for release in November. Theirs has 5 square meters on top, and it's also quite efficient, 0.9 liters equivalent per 100 kilometers. So it recharges 12 kilometers for every hour it sits in the sun. And again, should not need to plug in for ordinary driving, and has a range of 725 kilometers. In other words, the charging infrastructure that most electric cars would require, these two aim to bypass. And even they can be further improved. These kinds of efficiency, of course, also relieve, to a considerable extent, the burden on battery minerals. You can use new battery chemistries that contain nothing scarce, costly, toxic, or flammable. You can recycle batteries. One of the founders of Tesla, J.B. Straubel, has an exciting firm I visited called Redwood Materials that has millions of batteries being recycled routinely into pure new battery materials, and they go right into new batteries in the Tesla plant down the road. You can make batteries last much longer. You get a lot of leverage from the composition of batteries. For example, the older smartphones contain an especially high amount of cobalt, one of the most problematic minerals, so much so that you can support 30 times more new automotive batteries than your smartphone battery just by leveraging that high cobalt concentration in recycling. You can use the materials much more productively. Batteries are getting more effective all the time. You can improve the efficiency of the vehicles by 2 or 3-fold. You can go to a service model rather than selling a vehicle. So the vehicle has very much higher than the normal 5% utilization, sitting idle 95% of the time. And you can also make markets in kilometers and trips and make ways to get around, compete with ways not to need to get around because you're already where you want to be and don't need to go somewhere else. And collectively, these are rather large opportunities that can make the battery materials issue very manageable, if not relatively unimportant. I should say a little bit about the carbon fiber also. It's not the only way to make cars very light, but about 2/3 of the energy needed to move a car is caused by its weight. And every unit of energy you save at the wheels by taking out weight or drag or rolling resistance avoids, in a normal fueled car, about 4 or 5 units of energy loss in delivering the energy from the fuel to the wheels, and therefore leverages about 5 or 6 units of fuel saving at the tank. So the most high leverage thing you can do would be to take weight out of the car, and you can do this very safely if you use materials that absorb, say, 6 to 12 times the crash energy per kilogram of steel, and do so more smoothly. One of the obvious choices widely used in aerospace and sporting goods is carbon fiber composites. I brought along a couple of small pieces that would fit conveniently in my bag. Let me see if I can illustrate the metallic-like sound of these. And they have about 7 times the performance per unit weight of steel, but we developed a process early in the last decade for making structural car parts out of this stuff at very competitive cost and speed, and we sold it into the supply chain, the German Tier 1 pressmaker Diefenbacher, in 2013. The version they offered even 6 years ago can make a 2 by 2 meter very complex structural car part in 1 minute. If you want, you could do it several times faster than that, and at a competitive cost. So that technology keeps progressing, and so do many others relevant to cars, some of which are, I can't say much about, but really do reinvent the wheels. Now, the same physics and the same business logic apply to heavy vehicles as well. Long ago, we helped Walmart's heavy truck fleet save about half its fuel, and that did include smarter logistics, but current technology alone can profitably make heavy trucks 2 to 3 times more efficient. The 2 is well demonstrated. The 3x should be demonstrated this year by one of the major U.S. truck makers. And if you used the best digital engines, probably that stretches to about a factor 4. Now, at the same time, the 3 to 5-fold more efficient airplanes, already designed a decade ago by Boeing and NASA and MIT and others, would combine with the trucks to move about $1 trillion net present value from oil owners' top line to just Americans' pockets, and then multiply by some factor for the rest of the world, and of course help to get the world off oil. But again, technology moves on. So Tesla's battery electric heavy truck, it was supposed to be in mass production by now, but they postponed it, not because it's not ready. It's in customer testing. It's been ready for a couple of years. But they want to have the battery manufacturing for the latest high-power cells catch up, and the car making catch up with demand first. So they put it off till next year. And it will more than triple the efficiency of standard 18-wheel diesel trucks. It has 40% sleeker aerodynamics. The lightweighting offsets the battery weight, so it has at least normal payload. After all, you're saving 3 tons of diesel powertrain and fuel. That helps offset the batteries, and then you take a bit of weight out of the rest of the vehicle, but there's still a lot left to do on that. And at low U.S. fuel prices, as we had till recently, it would pay back in under 2 years. Now, you might not expect the next bit of news. There's a little company in Los Angeles that is flight tested, and I visited a business airplane that could fly, say, from Aspen to London, or probably Stockholm to Atlanta, or Miami, nonstop, with 1/6 the operating cost and 1/8 the fuel of a normal business jet. And it does this partly by light materials, partly by having one pusher propeller in the back, run by a twin aluminum 6 diesel engine designed in Russia, built in Germany, and the 2 halves are isolated, so they count as 2 redundant engines. But also, importantly, it has completely laminar aerodynamics, very smooth airflow over the fuselage, the wings, and the tail. The whole thing is laminarized, which is not usual. And that together gives the factor 8 or so efficiency improvement at much lower cost. It's obviously a candidate for electrification. They've also designed a version twice as big, which instead of 6 luxury seats in a big cabin could hold somewhere in the high 20s to mid 30s of seats in a quite comfortable configuration. And that size is ideal for the emerging point-to-point route architectures instead of hub and spoke, which are really a monopolist trick, where you want to go from A to B, so they send you from A to C, where you act as self-sorting cargo, and get on another plane going to B, where you wanted to go in the first place, and then you find they lost your luggage. Obviously, this is designed around the convenience of the carrier, not the passenger. So there's more and more call for point-to-point route architectures with more but smaller planes going exactly where you want to go, non-stop, and something with this 4,500 nautical mile range would do that very nicely. And I think this design alone looks set to blow up aviation's business models. And now even higher efficiencies are emerging. For example, NASA has tested almost 5-meter-long structures, which work better than expected in the wind tunnel, for replacing, say, airplane wings. And if you make a metal airplane wing instead as a lattice of little spindly molded engineering plastic cells assembled by swarms of programmed robots or graduate students, whichever are cheaper, and cover it with a tough polymer membrane, you can save 98.3% of the weight. And because of the properties of this wing mechanically, very strong and tough, it deforms itself to morph in a way that optimizes the aerodynamic shape for the real-time flight conditions without needing movable flight surfaces to do that. So that suggests a breakthrough in economics, weight, and aerodynamics. You could actually take this sort of cell and lattice structure, which is prototyped already as a car for Toyota and an airplane for Airbus, and you could make it into a vacuum balloon, which is strong enough not to crush, but buoyant enough to float up in the atmosphere without any helium. It's even lighter than helium because there's nothing in there. It's just a vacuum. And a really big one could lift about 24 times the payload of a jumbo jet. Might be quite useful for delivering things in remote places. Now, back to autos, they're not just heading for 4 to 8 times higher efficiency, roughly 2 or 3x from better car physics and the rest from electrification. They're also being driven less. Many young people don't want to own a car, even in car-ridden societies like my own, because it's cheaper and easier not to. It saves you maybe $10,000 a year not to have a car. And, of course, now our smartphones bridge these once annoying route gaps by summoning ubiquitous transport services on demand. But if you ever do need a car, you don't have to own it, just as you can have a great meal without owning the restaurant. And in some Chinese cities, renting a Condu electric vehicle from a giant vending machine costs about $3 an hour. And also, of course, if you rent shared cars when you need them, you can boost their 5% utilization by about tenfold. And there are now peer-to-peer platforms that let you rent out your car by the hour in a way that gracefully handles insurance and accidents and things like that. So some of my grad students at Stanford actually do this and pay for the car that way. And meanwhile, efficient and electric autos are morphing from pigs, that is, personal internal combustion, gasoline, steel-dominated vehicles, to SEALs, that is, shareable electric autonomous lightweight service vehicles, mobility as a service. And so that's 2 changes in technology and 3 in business model. They're all simultaneous, they're all mutually reinforcing, they're all vigorously in play, and they are sped by smart policies and commercial ambitions, which are really intense in India and China. And meanwhile, the rules are changing. You know, in 2010, half the world's new cars were sold in China, where only 5% of people owned one. But then they had a 100-kilometer traffic jam that took 12 days to clear. You can imagine this got politicians' attention, and they realized that building roads causes traffic. So they started changing the rules to ensure that drivers get what they pay for, but pay for what they get. So, for example, in Tokyo, to own a car, you must own a parking space. Denmark taxes new cars 180%, plus 95% duty if they're over 2 tons, plus an annual tax on inefficiency. In Shanghai, a license plate costs more than the small car you put it on. In smoggy Beijing, they will register your electric car instantly for free, but if you want to register a new fueled car, you enter a lottery in which you have about a 1% chance of winning the right to get the car, or actually the registration. And in central Copenhagen and Helsinki, they're phasing out cars in the city center. Singapore and Oslo inspire London's nearly $40 a day to drive your car downtown, and that shifted the peak period commuting to 85% public transit and cut congestion 30%. And then, of course, I'm not even getting into two-wheelers, of which there are hundreds of millions now in China alone, many replacing motorcycles and maybe a fifth replacing cars. And meanwhile, non-automotive mobility is improving as well. Do you know bus rapid transit? It's like a surface subway, and it's carrying let's see, over 200 cities worldwide are carrying over 30 million commuters this way. So it's a thing that looks like a bus. It pulls up at a platform where people have already come in and paid the fare. The big doors open all down one side of the bus and you come in. Meanwhile, people whoosh out the other side, and you can do 1-minute headways. So you get the route density of a subway, but at about 5% the cost. And in say Hangzhou, you can look at a horrible traffic jam and then look at the before and after picture, and the after is a nice clear street because 800,000 people are now on the bus rapid transit. The city most to watch is Shenzhen, which had 100% electric buses and taxis several years ago. They're approaching 100% electric delivery vehicles. It's a city of 13 million, and it has more electric buses than the top 5 American urban bus systems have total buses. And finally, urban design is changing as well. China plans in the next 15 years to build new cities for about as many people as America has. And so far, China has been designing cities around cars with an arterial vehicle network, 14-lane boulevards you can't get across that chop the city into discrete pieces. But instead, if you integrate and distribute where people live, work, shop, pray, play, that means people don't need to travel far, and they don't need to travel by car. So if instead the map looks like a capillary web designed around feet, not tires, you get 2/3 less driving, you need 1/3 less concrete, you have a much more pleasant green city full of parks and the like, and you can build a human ecology with vibrant commerce, rich social life, but equal or better throughput, cleaner air, happier citizens. There are over 50 cities now doing this, and more to come, and they will not use much oil. Where all this leads is that the oil and gas reserves that are unsellable for competitive reasons are probably bigger than the reserves unburnable for climate reasons. Oil owners are more at risk for market competition than from climate regulation. The cost of getting automobiles completely off oil has fallen from $18 per saved barrel a decade ago to under $7 today, and it's heading below zero in the next few years, even as fuel prices spike. So oil has become uncompetitive even at the low prices we had before Putin's war, before oil became unavailable even at high prices. And that oil story, I think, will resonate through energy security, climate, health, equity, and prosperity for a long time to come. Thank you.
Thank you, Amory. As usual, a lot of compact information with some brilliant ideas and some facts that you reported so quickly. I'm not sure everyone remembers everything, but luckily we are not university students who have to sit the exam. We can actually just enjoy remembering what we could remember. But I think there are some of the ideas that are definitely worth emphasizing and repeating. And the first one, which you have preached, I would almost say, for decades, is the fact that large energy efficiency improvements can be more profitable than the best small marginal improvements, for the reason that with substantial energy efficiency you can avoid a lot of compensating energy providing or power providing investments. And your first example was the house, where spending enough on insulating the house and have efficient energy, what call it, sort of heat exchangers, värmeväxlare, you can avoid a heating system, even in cold climate, including Sweden. And you said then that the same applied for cars. But then you have a set of different sets. One is the internal combustion engine cars, where you just reduce fuel use, you don't get rid of the engine. But then you came to the electric cars, and you said if you do a vehicle efficient enough, you still need an electric motor, but you can do without the charging infrastructure, right?
And the motor gets very small.
Right. So you still save even with a smaller engine, and then you save enough. So if you're not living too far north in Sweden, you can avoid even having a charging infrastructure, because you can rely on the solar insulation. You said that was true in some US cities, seems to be possible in some parts of Europe. How far north would you dare go, saying that you could drive a car for daily commuting, maybe 30, 40 kilometers without having charging? Just
if you go to the aptera.us website, they have a little global calculator that says how many days a year, given normal weather statistics, you would expect to have to plug in your car in order to do a daily commute cycle. Mm-hmm. And it's really an astonishingly small number, even in Scandinavia.
When you came to the airplanes, you showed, and then it's weight is one, the drag, the air resistance is another important factor. You showed how technology had evolved on both these grounds, and you talked about the opportunity of small, low-cost, energy-efficient plane replacing bigger planes with the same cost, making possible direct relations.
Actually lower cost.
Lower cost, sorry. Making possible direct relations between cities. Instead of flying from A to B in order to reach C, you could fly directly from A to C. You could have a larger number of airplanes flying with smaller cabins, fewer people in each plane, and still provide cheaper transport than the big.
And much more convenient and time efficient for the passenger.
For the passengers, yes. And how far can this go? Have you got? You did mention some relationships, but how far do you think these planes will be able to operate? What distances?
Well, the one I talked about can go 4,500 nautical miles, which is roughly Stockholm to Miami, I think.
Mm-hmm. So, and then it was a fuel with a fuel engine. It was not the sort of
yes, and it can burn any fuel actually, including biofuels.
Yeah. We have in Sweden a company now called Heart Aerospace that is developing a 19-seat aircraft that they claim will be able to operate on relations up to 500 kilometers with electric motors. Have you looked at them?
Yeah, there are about 150 or so aerospace startups, of which that is a prominent one. And I think it's now highly likely that electric airplanes, which would have been inconceivable a decade ago, except in special military applications, are likely to take over the short-haul market rather quickly. Norway is among the leading countries in doing that. The surprise, I think, is that as batteries and airplanes get more efficient, the electric airplanes will probably dig rather far into the mid-haul market as well. And then the long hauls, the transoceanic flights, will probably go to liquid hydrogen, so-called cryoplanes, which can work very well. They are a whole new kind of plane. You don't just convert them, but there are also some other possible developments that could even electrify the long haul sector, but those are still in the lab or speculative.
If you look at companies like Heart Aerospace and you compare them to the best technologies that you described for air drag, for example, do you have any impression how well they are doing compared to the
I don't think they're as good as say auto aviation, whose founder, by the way, was chief scientist for avionics of the B-1 bomber. He does know the business. But they're quite good, and I think Heart and its competitors will all gradually migrate into that efficiency category, and that will make their range and cost and weight much more favorable.
In the Swedish debate, there is a lot of anti-aviation discussion, because the aviation emissions of fossil carbon dioxide is growing fairly rapidly, unless not for the last 2 years, but before that, and maybe now in the last few months. And that's considered to be a very big climate problem, and has a distributional effect where the richest people fly most, and seen as a very bad thing. Do you think that the attitude towards aviation will change, or will because of this development that makes it possible to build airplanes that are even climate neutral with electrification for the short haul?
Well, some attitudes should change when that happens, and it's really the industry's best shot at becoming sustainable. And at the same time, our airports have a lot of land, which will start becoming solar farms. It will be an energy hub, and not so much fuel as electrons, and possibly hydrogen.
Yeah, and I know Heart Aerospace also claims that they don't need the full runway of a conventional airplane, so they can do it with shorter runways.
That's right, and there's also a lot of vertical takeoff and landing, electric aviation, things kind of like a little quadricopter drone, but bigger, that can take you with or without a pilot in a kind of air taxi mode. Some of those are likely to enter the market quite soon, next year or two, and those actually could be quite disruptive, because they could take you downtown to a kind of stalk and plate arrangement like a mushroom that has almost no urban footprint, or land on the top of a building. Of course, all this does raise another set of issues, because if you like congestion in 2 dimensions, you'll love it in 3 dimensions. And there are obviously some safety and security issues to be worked out very carefully.
Right. And that I think you alluded to the fact that some of these technological developments are made difficult by regulation.
Yes. And in fact, the Federal Aviation Administration in the U.S. had a rather large program going to figure out a whole new regulatory scheme for drones, but then the technology moved so fast, they had to scrap it and start all over from scratch. And that's been pretty disruptive as well.
Right. I had some colleagues in Sweden who tried to design a very low-weight electric passenger boat. And then the safety authorities said that that's dangerous because plastic can burn. We need steel that cannot burn.
What are they thinking?
They were thinking that it's easy to say that steel cannot burn.
Well, but
it's more difficult to say that something else cannot burn, and things that burn on a passenger ship are dangerous. Yeah.
There are a lot of plastics that you can play a blowtorch on and nothing happens.
Right. Yeah. Once I questioned you or moderated you at a conference, and I said, when you have all these fantastic technological ideas that you can show are economically profitable. And I asked you, why don't they happen? You protested and said they do happen. So I modify the question. I say, when you have all these wonderful ideas that are technologically possible and economically profitable, why do they happen so slowly?
Thank you. I think that having been at this 30 years or so on the automotive side, I'd have to say the barriers initially appeared to be technological and then economic, and now we know they're neither. They're now cultural, which are real. And indeed, in the BMW case, the unhappy ending was that they hired the wrong CEO who had different strategic ideas. The team dissipated. Actually, the guy that so brilliantly ran the program, Ulrich Krantz, is now working for Apple. Isn't that interesting? And, oh, by the way, the head of advanced composites at Apple is the guy that developed this manufacturing process. So there may be something to be heard from. I think there's a couple of basic points here. I should hook to your question. One is, because electric cars are taking over so rapidly, faster than practically anybody had forecast, it is easy to suppose that solves the automotive car and oil problems. So, task done, we can move on to something else. No point getting efficient. The electrification is itself efficient. Well, there's different kinds of efficiency. If you first take out half to two-thirds of the energy it takes to move the car, it's much easier and cheaper and faster to electrify. It would be better to do it first. You can do it afterwards or along the way. But obviously, what I call platform fitness or platform physics should get right along with electrification in whatever order they happen, because that will save lots of batteries and recharging infrastructure and energy and so on. But this is not only the province of governments. For example, there was a Bloomberg New Energy Finance bulletin 5 quarters ago saying that by 2030, the flagship Chinese cars, not the average, but the most interesting new ones, will use about 4/5 less iron and steel than they do today, and their structure will be made of carbon fiber. Well, there is a certain senior Chinese official in charge of automotive strategy who thought that was a good idea when I started talking to him about it maybe 10 or 15 years ago. And I suspect he might have won the argument by now. I'll have to call him up and see if that's what happened. But that would be enough to flip the global auto industry. Another possibility, I mentioned that BMW hired the wrong CEO who only lasted 1 term. But the guy they passed over, who had been backing the carbon fiber strategy, then became head of Volkswagen. It might occur to him that since it's really hard to compete with Tesla just on volume, maybe he should ultralight Volkswagen's 11 brands and get his economies of scale in doing that, and save most of the batteries, which are his biggest cost and hassle. So that might be another way that this could flip the industry, because Volkswagen is the center of gravity of the whole industry. So we have a couple of ways to make this happen. Now, we had a shot at it at RMI with one of our little spin-offs, but it came to market for production capital just as the capital market disappeared in November 2000. Bad timing. But then a lot of automakers came to us and said, that's a really interesting design. We understand strategically why we must make it, but we don't know how. Can you show us that your conceptual process for making carbon fiber car parts actually works? So we did, and put that in the supply chain. And now most of them have carbon fiber supply chain worked out. They're kind of ready to go, and the cost is dropping. And
But there are a couple of university professors in this tent, and
at least two.
Even more, I can see in the audience. And I know that there are among them sometimes frustration that we're quite good at finding the technologies, some of which you described in textbooks and research papers, but we tend not to be able to train people to do the successful systems that you also described. For example, this energy efficiency strategy. Why?
Well, automakers are very big, complex organizations which behave differently than individuals would.
Yeah.
And it is really hard to change that culture. Sometimes they have a near-death experience and that gets their attention.
Yeah.
And, you know, this is part of, I think, the secret of Tesla's grabbing such a big market, although it was just overtaken by BYD.
Mm.
Tesla's not a car company at all. They're a software and systems company. They just happen to make a bunch of things, some of which have wheels. But their business model has not been about being a car company, but rather integrating energy and other forms of value across diverse motor vehicles, buildings, and grids. And somewhere space gets into that.
Mm.
It's funny. Judy and I just signed up for their satellite internet service, and the terms of service say that the contract applies on or in orbit around or near the Earth and the Moon. That's the first time I've seen that in a contract.
But there's also this issue that I think deserves some attention, and that is the difference between technologies and system design.
Yeah. The car business is so specialized that among the 1,000 people or so designing a car these days, there's probably a right front knuckle specialist. And I'm not making that up. I met such a person. These firms are so complicated, it's amazing they work, and they're very good at what they do. And what they do is extremely difficult. It's got 12 or 14,000 parts, and it runs reliably for over a decade in all kinds of difficult conditions and with rather little maintenance. But it's not fit for purpose in the new world we're now in. And I think these startup car companies are much more interesting. They can move enormously faster, and they can actually piggyback on the existing infrastructure. So Lightyear is using a Finnish Tier 1 manufacturer to make its cars. It's not trying to get into being an automaker. That's a whole other business best left to people who are good at it.
Thank you. Matthias?
I think that... I think that I can safely say that rarely, if ever, have we learned so much in 45 minutes. And I think that I can also say that rarely, if ever, have we left a seminar so inspired by how much can be done and how logically it would be to do it, and how it's really only a matter of culture getting it done. And we are here at the 2030 Arena to make sure that every piece of that puzzle is being put on the table at the right time, so that by 2030 we in Sweden will be the role model that you use in your examples. We know there's a bit to go there, but we'll get there. Thank you so much, Amory Lovins, and thank you so much, Tomas Kåberger.